Okay, so welcome to the computational microelectronics. This is the very first lecture of this semester. Okay, I think that unfortunately, um, well, oops, sorry about that. Okay, so once again, welcome to the computational microelectronics course, and my name is Sungmin Hong. Yes, so I'm the instructor of this course in this semester. Okay, so first of all, I would like to welcome all of you to this course, and this course has a code number EC7114. So this means that we are in the 7,000 level course. 7,000 level course is intended for the most advanced course for our graduate study. However, so in order to fit to our actual lecture situation, so I can just adjust the level of presentation significantly. And here we have three lecture hours per week. So Tuesday and Thursday morning we will have two classes, and there is no experiment of course. However, instead of this no experiment, but you have tons of exercise you have to practice your own coding during this course, so that is a requisite for your course attending this course, and credit is 3. And my name is once again Sung Min Hong, and I'm currently affiliated with the School of ECS. Okay, let's go to the next page. So in this semester you will have several resources provided me. So first of all, there is the repository, GitHub repository for your presentation materials. Let me just show you how can you access the presentation materials. So for example, so in your web browser, so you can visit GitHub. Yes, then of course there you can find my name. Yes, and this is my ID, and unfortunately I'm not quite sure, but okay, let me just try. This is my ID, and here we have computational microelectronics 2024 fall semester. So when you just type the full name of my repository, then you will find this one. Can you see it? So this is my ID slash CM2024F, and when you just enter into this repository, then you can see that this PDF file for our lecture material. For example, this L1 means that your L1 material, and usually I upload my PDF file just before our lecture start. So maybe for example Monday night or Wednesday night you can see these files. And there is also another one, like already you have homework 1 and example 1, so please have a look at it. What you can do is just visit this repository and download your PDF file. So by clicking this download, then you will have the PDF file. Okay, so it's not that difficult to get your presentation material. Another one is we have tons of homework in this course. Actually, every day you have homework. So although there are not many homework problems, but each one should be implemented by yourself, and you must submit your code and report PDF format to me. So I would like to recommend you to use this LMS system, but currently I guess that only 4 of you guys just registered in our LMS system, because there is some time delay between your registration and actual registration in this LMS system. So for this very first homework 1, please submit your homework problem directly to me by sending your PDF report to me. Okay, so but this is just a temporary remedy, and basically you must submit your homework through this GIST LMS system, so you can easily know how to submit your homework problem. And there is another resource. It is my YouTube channel. So, for example, let me just when you just click sorry, instead of that, why don't you okay, so then you have my YouTube channel, and of course it contains a lot of recorded videos, but when you just go to the playlist, then you can find that this is the currently active one, so EC7114 for this semester, but also you can find another one like this one. This is for previous years. Another one, maybe yes, here you have another one. Also here you have another one. So I think that this is maybe 6th or 7th offerings for the same lecture course, computational microelectronics, and I guess that most of, not all, but most of my lectures are already pre-recorded or recorded in this YouTube channel, so you can find so many recorded videos on this material. Okay, so that's the reason why in this semester we will take a little bit different approach than our previous courses. So I will just explain it later. And evaluation. So evaluation means that how can I make your overall score to sort your achievement. So first of all, we have 1/3 rule in this GIST graduate school, but I'm sure that all of you will attend quite regularly, so I think that it's okay. And attendance means that just I will normalize your number of attendance using the entire number of entire courses provided. And second one is homework. So homework, basically you have every day, every lecture you have homework, and usually I give you just 2 or 5 days to perform your homework problem. So once after our lecture is over, for example lecture 1 is finished, and just before starting the lecture 2, you must submit your homework report to me. So between Tuesday and Thursday you have just only 2 days, but fortunately between your Thursday and next Tuesday you have a longer period. But anyway, I will give you everyday homework, so that will count 40% of our entire score, and final presentation takes half of your entire score, so 50%. So in this course, you must prepare and submit your own recorded presentation, not report, PDF report, but recorded one, so your voice and your presentation material, and it will be uploaded in my YouTube channel. So if you cannot understand this condition, then please stop enrolling this course. For example, when we go to our previous lecture courses, for example, yes, then here we have, this is just 1 year ago. Yes, there are many lecture recorded one at the end of this playlist. Then you can find that the previous submission by our previous attendances. Okay, so you can find that they made such kind of thing, and based upon the quality of their presentation, I will give first 50% of the entire score. So that is most important for your semester. So simply speaking, this course is heavy loaded, so you must prepare yourself to enroll this course. So please, this course is not for junior level students, so this is a kind of the most advanced one for our graduate study. Okay, so please understand this situation, and you must devote yourself to this course. Okay, then let me just comment a little bit more about this semester's lecture progress. Usually, when you have a look at the lecture materials already available in our YouTube channel, then you can find that actually I spent quite a lot of time to spend every detail of implementation. You can find tons of information about the actual implementation, but in this semester I feel that I have done it enough. So you can find so many already recorded lectures, so I don't want to repeat this kind of detailed explanation any further. So instead of that, in this semester I would like to expand the coverage of our entire lecture course. So previously, in our previous course, our lecture material was mostly restricted to the device simulation. Device simulation means that when we have a certain semiconductor device, we wanted to calculate the electrical property of this device. It means that electrical property means that, simply speaking, just terminal current of a certain device. For example, if you have a MOSFET, then you wanted to calculate usually drain current as a function of given bias voltages. So that is the main purpose of device simulation. So main focus of our previous offerings of this course has been limited to this device simulation. And in the previous lecture, the last lecture, so which was done in 2023 fall semester, I expanded a little bit to the process simulation. Means that now we wanted to calculate the diffusion of your dopants inside the semiconductor materials, or change of something anyway inside the semiconductor device. So anyway, this is just limited to the device simulation and process simulation, and instead of that I spent almost half of a lecture hours entire semester to the process simulation, and remaining half was devoted to the device simulation. Instead of spending excessive time or lecture classes or lecture hours to these topics already covered quite well, So I wanted to expand the coverage. And another one is the lecture progress. Usually what I have done was done in this way: process simulation and device simulation. And even in this device simulation, so we start from more complicated one to the more simplified one. So that was our lecture progress for our previous lecture offerings. However, instead of that, in this semester we will take the reverse direction. Means that starting from seemingly the simplest one, we will go to this direction, and eventually we will end up, if a lecture goes quite smoothly, then we will end up with density functional theory. So you will calculate the band structure of silicon at the end of this course. So this is quite much related with more physics related topic, but today we will start from just computer related topic. How can we implement the computer into our system? Starting from this more engineering related topic, we will move backward eventually to arrive at the atoms and their band structures. Okay. Okay, but anyway, when you have any question, then please interrupt me anytime. So you are more than welcome to interrupt my presentation.
Professor,
Okay.
I have one question regarding the coding language.
Mm.
Is there any limitation of coding language?
No, your language, so
Yes.
programming language. So actually, there is no limitation, but practically, I have seen some students have used C and who has used C++ and MATLAB and Python. Those four are main languages that our previous students have used. But a point is, okay, so my main language is C++, and also I know how I can use MATLAB, and also nowadays I wanted to study Python. So although I can understand all of these four languages, but usually what I do is not read every line of your simulation code. It's up to you. What I have done is just to read your report and see whether that gives you, that report describe reasonable result for our homework problem or not. So in my opinion, actually the program language itself doesn't make any difference nowadays, because we have so much advanced computer systems, so speed doesn't matter for usual cases. So I wanted to recommend you select or choose your own preferred language. So maybe nowadays many students really loves to use Python, and my presentation material will be also prepared by Python. Although I'm quite new to Python, I'm trying to adjust myself to this Python language. But our previous lecture materials were made from MATLAB, and of course my professional programming is only done with C++ because this is really performance limited. Okay, that was really good question. And what is your preferred language?
Actually, yeah, I am old school guy. Therefore, I am using the MATLAB or something like that.
Oh, okay. So that's no problem. Actually, MATLAB was my preferred language for preparing all kinds of these things. So also, okay, that is a good thing. And good question. And if you are really using this MATLAB, then you have another resource. So I have written a book together with Dr. Hongyan Park, and here you can see a book, and at the end of this book you have the solutions written in MATLAB language. So yes, maybe that is a little bit aid for MATLAB users, but actually in this course, in this semester, our coverage will be well beyond the coverage of this book. So maybe you have a limited coverage for our entire lecture. But anyway, if you are using the MATLAB, then maybe that can be a good reference. So you can find it in our library. Don't have to buy a book. Okay. And another one is, of course, if you are old school guys, for example, even you can use Fortran. Fortran is very good for calculation, and I have used during my postdoc researcher age, so I have used also Fortran. But anyway, in my opinion, our course itself is not that much performance hungry, not speed hungry. So we will use just a small system, so which can be easily debugged and checked. So you don't have to worry about the speed of your execution. So feel free to select any language you wanted to have. So actually, I wanted to recommend you explore a new language. So that will be my own pleasure. So if you, for example, if you bring me another language, not which I have not seen before, then I will be quite happy. And yes, so also that will be also fun to you. Anyway, that was a very good question. Thank you for your question. And let's go to the specific problem in our semester. Okay, usually I don't take many business trips, but in this semester, unfortunately, I have 3 different business trips already planned. So, for example, next week I will visit Bridges for attending an international conference, and next week, so I will visit also San Jose to attend another conference, and the beginning of December, so I will also visit San Francisco. So we have 3 weeks long business trips, and each of them is just 1 week long. So in this case, in many cases, I will provide pre-recorded lectures. For example, our third lecture, lecture 3, and our fourth lecture, lecture 4, will be provided in the format of pre-recorded lectures. Then where can you find it? Actually, you can find it in my YouTube channel. And by the way, our live lecture, this lecture itself is being recorded. So after the lecture is over, and then when you want to review our lecture, then you can visit my YouTube channel. Then your question and my answer, that is already recorded and live streamed. So, but don't be hesitate to ask any questions. So usually the number of viewers is quite low. Nobody care about our lectures, so you don't have to worry about the anonymous thing. Okay, so lectures 3 and 4 will be provided in the format of a pre-recorded one. So also another one is lecture 5 will be Tuesday. We have Korean Thanksgiving Day, so we don't have any lectures, usual time for our L5. So this is Tuesday, but we have no lectures, and lecture 5 will be made on Thursday. After that, you have a lecture 6 and lecture 7, but in that case, I'm also in San Jose, so I will just upload once again 2 recorded lectures. So I will just set up the upload schedule corresponding to our usual lecture schedule. So when 9 o'clock on Tuesday or Tuesday and Thursday, you will see these lectures. And finally, for IDM, so San Francisco case, I'm not quite sure I will upload the presentation material or lectures or not, because this is quite close to the end of our semester. I guess that maybe all of you are you will be quite busy to performing your term project for your final presentation, so maybe we will have no lectures. That is not that much determined, so you will see it later. Okay, so I have already spent 30 minutes to explain the admin related stuff. So do you have any question? Then please ask me any question. Once again, is more than welcome. You are more than welcome to ask me a question and interrupt my presentation. But it is possible only because actually many of lecture contents are already available in the web. So especially in my YouTube channel, you can actually find so many repeatedly recorded videos. So you can explore that channel. Okay, so if you don't have any further question, then let's get started with seemingly quite different topic, usually not covered in our computational microelectronic course. I think that this is corresponding to the upper boundary of this course. I don't want to expand any further to the higher level, so maybe that will be the most abstract one we will see in this semester. This is instruction set, so SAP-1 instruction set. This is as simple as possible. So this is not really not a practical instruction set. This is just for textbook and for education. However, I bring this material to you because the main theme of our lecture in this semester is how can we implement TCAD tools. Wow, TCAD tool here means that technology CAD, you know CAD, and here technology means that the technology to fabricate semiconductor devices. Simply speaking, the technology to make MOSFET, and by using this MOSFET, those MOSFETs, you will make a chip. Yes, and why do you make a chip? Because you wanted to eventually make a system. So usually the coverage of this course is just limited to this one. How can you implement the TCAD tools? But as I told you before, in this semester I wanted to expand the coverage a little bit further. So if we just draw a horizontal line here, then here you can see that something more related with physical reality. So because our MOSFET is not in the air, but we must make it by using our silicon and its oxidized form or other kinds of metals. So we have to understand physics. So this part is here, and here we have a chip, but we are not designers. Of course, some of you are designers, but I'm not a designer. I'm not that much interested in the circuit design, but I'm interested with the computer program to support our circuit designers. So we will talk about how can we implement also certain program to support circuit designers. And the topic we will not cover extensively is a system. Here we have a system, and what is a system? What is a simple example of a system? One example is a calculator. For example, the calculator which can calculate something like 15 plus 15 becomes 30. So we need to understand the system. Although that is quite simple, 15 plus 15 can be quite simple, but what we want to know is like this: add 15 and 15, for example. If we write down in this way into our memory, then this machine, this hardware, can calculate 30 as a result of this add action, addition. So we wanted to talk about simple example of a certain system. So as an example of this system, I have dig out the web page, and we have found that SAP is possibly one of the most simplest one. So I will just quickly cover this contents, but that will be just limited to today's lecture, and already in lecture 2 we will move to more concrete version like MOSFET or something like that. But before starting such kind of transistor level consideration, first consider this system level consideration. Okay, well, in my opinion, the main point is programmable. So you have a certain system, but that system have memory, and it can load the program. So here you can see that this is an example of your program. So how does it look like? It just contains only 0 and 1. And can you understand what is the meaning of this program? Well, it's difficult to understand. So let me just explain it a little bit further. Okay, so in your program you have 16 by 8 binary numbers. So for example, here you have 8-bit binary numbers, and that is just memorized in an address of 0000. Okay, so then here you have another 8-bit binary number, and its address will be 0001. So you have different numbers, and here you have just 16, only 16 binary numbers. Okay, then it may read like this. So let me just give you the first line. Yes, this is one 8-bit number and another 8-bit number, and here you have another 8-bit number. When you count the number of these 8-bit numbers, you will find 16 of them. Okay, so when you have a look at your homework or example file, then you can download this input file from your GitHub repository. Please download this example input file and homework input file into your local computer. And what you have to do in this in this lecture is to write a program to execute this program. This is although quite simple, but this is a program, and in your program read this input file and perform the expected behavior. Okay, so are you with me? Then let me just come back to this one. Of course, if we don't have any instruction set, then that will be this one will be just a stream of random stream of 0 and 1. But if we have some promise between or among us, then each of them can give us a certain information and meaning. So let me just explain what is the meaning of this each row. Here each row means that 8-bit binary numbers. There are 16 rows, and when we have a look at each row, then it looks like this way. Then it contains 4 more significant bits and 4 less significant bits. Okay, so this one is the most significant one, and this one is the least significant one, and the first 4 numbers are corresponding to the instruction, and the second, the last 4 bit is corresponding to the address. So please have a look at it. For example, let me just come back to our example. Here the first row just reads like 0 0 0 0, so it means that our instruction is 0 0 0 0. Okay, then what is the next instruction? Can you recognize it? So when you have a look at the second row, then your instruction is corresponding to 0 0 0 1, and third one is 0 0 0 1, and fourth one is 0 0 1 0. 1 1 1 0. You have different instructions. Of course, they don't by itself or by themselves, they don't have meaning, and we must make a certain convention. This is the convention. So when it is all 0 numbers, then the or register called as the accumulator is loaded, and after that 0 0 0 1 is corresponding to the integer addition, and 0 0 1 0 is corresponding to integer subtraction, and 1 1 1 0 that is corresponding to the printout. You can now see your output in a screen. After that, this 1 1 1 1 is corresponding to the start the program. So please have a look at this program. Then how does it look like? It means that starting from this load, after that you take the addition once, and after that this is corresponding to subtraction, and print out your result and end the program. So simply speaking, it performs the addition action operation twice, and subtraction once, and print out your data and end the system. So that is so simple. So then I have to explain the second part of this address field. For example, here we have 0 0 0 0. It means that corresponding to the load the accumulator. Then what is the meaning of load the accumulator? Which value itself is loaded? For example, here we have 1 0 0 1. This is corresponding to the decimal number of number 9. So it means that we load number 9 into our accumulator, but it's not. This is a long description about this operation. Instead of this kind of thing, this second field, second 4-digit number should be regarded as not a value but an address. So it means that in this case they or this hardware try to find out the contents stored in the ninth memory system. So where can you find the ninth contents? So let me just look at this one. Okay, I'm not quite sure. For example, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is ninth memory. So actually what we do by performing this first line is, instead of having number 9, but your accumulator now takes the values like 0, 0, 0, 1, 0, 0, 0, 0. Why do we have this result? Because this numeric value was stored in the ninth memory point, and our LDA operation just to point out the ninth operation. So quite similarly, this address field just to point out the which address should be used to perform this kind of addition operation or subtraction operation. Yes, so for example, let's go to this one now. Okay, so when you perform your homework number 1, you must introduce some variables, and I would like to recommend you to implement those kind of variables in your program. For example, one variable is called as lamp. Of course, it has some meaning that is corresponding to your memory lamp, and it is 16 by 8 array. And what is the contents of this lamp? So of course your lamp should consider this information. Okay, and another one is PC. Yes, this PC is called as a program counter, and it changes from 0 to 15. So it means that starting from the zeroth line, the program just to go to the 15th line. Sequentially, each row is executed. Okay, and in this simple system, you have only 2 registers. Registers means that each of them contains 8-bit number. Yes, and 8-bit number, and when an address is pointed out, that information is loaded to the register A or register B depending on the instruction. After that, since we are now implementing calculator, we have a sum and diff. So as a result of your sum, what is the result of your subtraction, you have this temporal variable that should be eventually copied to your register A. Okay, so you will see what is the actual meaning of this one. So first of all, please write down your code to read the input file. For example, sap1.imp. That is your input file available in our GitHub repository. Then please load that text file and load it into our LAMP system. So here you can see that. So this is 0, and this is a 15, and you can see exactly each line is corresponding to our SAP 1 input file. Then where can you find the instruction, and where can you find the address? This is corresponding to instruction, and this is corresponding to the address. So then in your program, once again, you should pass each of your memory. Then please change your PC starting from PC equal to 0. Then read this line. Then by using these very first 4 binary numbers, then you can find that, oh, this is corresponding to the load accumulator. Then some contents is loaded into the accumulator, and the address is given as 1001. Then this program should find out the contents in its 9th one, and that is loaded into register A. So after this execution is over, then you must have your register A value is corresponding to 0001 0000. That will be your correct operation. Okay, so by the way, I have one quick caution about MATLAB users. MATLAB is based upon the one-based array. So the very first contents of your array start from 1. And for many other languages, it starts from number 0. For example, in this example, when I say number 9, but actually it's not the 9th element of your memory RAM. Actually, it is the 10th element of your memory. Okay, so when you are using the MATLAB for your familiarity or certain ease of programming, then please be careful about using this one-based notation. In this course, I will exclusively use a zero-based notation. Okay, so that was the first line, and here you have second line and third line. Oh no, this is a second line, and I guess that this is maybe corresponding to your fourth line, and this is corresponding to add operation, and this is corresponding to the subtract operation. However, the principle is quite easy to understand. Now, since this is add, now we will just take the address 10 here, and this 10th component will be copied into our second register called register B. Now register B is loaded with the contents of this one, and they will be added. They will be added, and temporarily that will be memorized in some register. Actually, this is not a register, but this is just a logical output, and this sum will be eventually copied into your register A. So then what happens in this ADD operation? Already you have register A, but now your register B is added and just memorized in your register A. That is the situation we can see in this operation. Also, when you have a look at our subtraction example, the program is the same. Yes, the address is taken and register B is loaded with the memory location at 1100, the address field, and it calculates register A minus register B. So this is your homework problem. You must write down a program which can perform this kind of thing. Another one is, now you have output and halt, and when you have output, then actually although you have 8-bit number, here we have x and x and x. If you have already attended other circuit related courses, of course digital circuit related courses, and you will find that these are called as don't care. So whether that is 0 or not doesn't make any difference. It means that this is something like a wild card. So it means that 1 1 1 0 0 0 0 0 1 1 1 0 0 0 0 1 up to 1 1 1 0 1 1 1. All of these 16 cases will be treated as the same case, because once this instruction is 1110, then we do not care about this address field, because this is just print out, so the address is not needed, so the contents inside this address field doesn't make any sense. So that's it. So here you can see that. So in your homework problem, you must print out the contents of your register A to your screen. So in this example, SAP1.imp, if you do it correctly, then the output should be this number. So please, if you do it in a binary format, your result should be this way. And finally, 1111 is corresponding to the halt. Then when we meet this 1111, then program is immediately stopped. So please, let's come back to our example input file. You can see that starting from this 0 address, you can see that this is the 5th line is corresponding to the halt condition. After that, all kinds of this information actually are not used. So your memory, your program is loaded in the lower part, and here you have just garbage information that is not used any further. And at the end of this memory allocation, then you can find also another one starting from, I guess that maybe this nice one. So this part is used to actual numbers. For example, the first part just to give us addition or load, subtraction, and actually which numeric value is added or subtracted, that is determined by this part here. Actually these numbers are added or takes the difference. Okay, so for example, if you do it correctly, then your program should behave like this. Actually, all of other things are just optional and only for my own debugging purpose. The thing you have to have is this boxed line, boxed area. If you have a printout, then your system should give us this information. So addition of two numbers and take the subtraction, and that number is printed here. All other lines are just for my own. Okay, for example, when I have a look at 0000, I recognize that this is LDA. Or 0001, I recognize it as addition and subtraction, out and halt. All kinds of these information is just optional, but your program should give us this correct information. Please try to implement this one. Okay? So although sounds quite simple, but this is actually the very basic implementation of our calculator. Main point is now we can program it. Means that once you have a certain program, and by changing only your program shown here instead of our SAP1.input, if you use HW1.INP, then you can reuse the same hardware to calculate different operation. Please try to what is the operation done by this program. Okay, you load something and add. After that, print out your data. Once again, you load something and just print out and end. So this is different from our previous program, SAP.inp. So it means that once you build such a hardware system, then only changing your memory component, then your hardware will behave completely differently by performing or executing this program. Actually, that is the although quite simple, but that is the way we build a hardware system called as a computer. And you can see that once we can implement each of these components, for example, addition or subtraction, and controlling those things and comparing those numbers, then we can build a computer system. Of course, this is not our main lecture topic in this semester. I will just showed this content to improve your interest on this subject, and our next lecture will be devoted then how can we implement, for example, addition, how can we implement on binary adder. So you will find that actually building a binary adder is quite simple and straightforward by using our simple logic gate, and by using this logic gate we can make adder and subtractor and other digital component, and eventually we can get a simple calculator. Of course, it will spend more effort than even we can make not just a simple calculator but computer or other kinds of arbitrary binary or digital system. Okay, so let me just wrap up today's lecture. Now you have homework number 1, and this is a new thing. So please, first of all, write down your program and test with SAP 1.input file. And once your program behave quite regularly, then please try to also homework number 1. But I wanted to ask you not just to learn and screen out this calculator result. Please try to find out the correct answer by manually reading this line. So you can do it. For example, this one 000111 means that you have to load this information into your A register, and this second line just shows that this one should be loaded into register B and should be summed, and yes, your loaded register should contain A plus B. Yes, so you can do it by manually and check whether your calculation result is exactly the same with the one done by your own program. Okay, so yes, so today's lecture is now over, and do you have any question? Then please ask me any question. As I told you before, since some of you are not in our LMS system in this time, you don't have to submit your homework through LMS system. Please directly send me on email, and the due is just 8 o'clock on Thursday morning. Okay, I will check your submission time, and there is one important rule. There is no late submission. There is no late submission is allowed, and most critically, yes, you can miss some of your, for example, some of your homework submission. However, that rule also applies to your also final presentation. Even in the case of final presentation, I don't accept any kind of late submission. So please keep your schedule. So since this is 50% of your entire score, so late submission will just demolish your entire semester. Okay. So do you have any question? Okay, so we have tons of things to cover. So I think that today, in this semester, especially in this semester, our lecture will be even more interesting than our previous one, because our coverage is highly expanded. So we will learn much more than our previous courses. Okay, thank you for your attention, and I will wrap up today's lecture. And if you